Hello guys, welcome to Hardcoder. Today we are going to see the read code problem number 76 minimum window substrings. Let's get into the question. So the problem statement is given two strings s and t of lengths m and n respectively, return minimum window substring of s such that every character in t including duplicates is included in the window. If there is no substring, return an empty string. So the test cases will be generated such that answer is unique. A substring is a contiguous sequence of characters within the string. So this is the given problem statement, and they have given that S and T will be consisting of uppercase and lower characters. So let's dive into the approach. So we have considered the first case which is given in the uh, given question. So the approach we are going to use is, so we'll take every window in the given string and check whether the given window contains all the character in the string t or not. This is the approach we are going to use. So we can see that we can have many substrings for the given string. So in order to minimize the time complexity, we can consider only the substring. We'll select the substrings based on sliding window. Why we are using sliding window? Because if we check for every substring, that is this, when we start with a, that is a, we can see all the possible substrings, like it will be going on till every substring. So we next, after checking with a, starting with a, we need to start with other indexes. So this will be taking a large time complexity. That is, firstly we'll choose a, then ad, then ado, and every time we'll be checking with the string. So it will be taking a time complexity of s length will be, let's say s length is n, so n into n. This is the time complexity taken for this approach, that is finding every substring and checking whether the substring contains every character in t or not. This will be taking the time complexity of n cube, which is pretty high. So can we find a better approach to solve this question? Yeah, and the answer to the question is yes. So how can we do it? So we will be using a property called sliding window, in which we'll have a window which will be consisting of any elements, any number of elements, characters, and it will be the property of the window, the size of the window can increase or reduce. It will be increasing on the right hand side and will be reducing on the left hand side. We are going to use the sliding window. So how can we use it? So let's consider the given question. So A D O B C. So this is the given test case, and here other characters A, B, C. So firstly, we'll take the we'll have three variables, that is n, which will be used to represent the minimum window size which we have found till now, and we have two variables, integer variables, which will be which will help us to keep track of answers start and answer end. Initially they will be given as -1. So firstly, uh, we'll consider the window of size 1. So we'll check if the window contains, we have a count variable which will be storing number of character that is present in the current window, which contains the characters in string. So initially the count will be 0. So initially count is 0. Firstly, we'll have a into our, we'll include a into our window. So the a is present in the t, so we'll increment the a to 1, and we'll move on to d. So d is not present in the current. D is not, character is not present in the t. So we'll increment to o. We'll increase the window size to o. So in when we include O, the condition, that is the given window does not contain every character of T. So we need to extend the window size further. So we'll increase to B. So whether it contains every character in T. So the current window does not have every character of T. So we'll increase the window size further, and we'll check whether the current window has every character of T. Now too it doesn't have, because there are only two characters, that is A and B. That is A and B. So C is not present in the current window. So we need to increment the window size. So we'll include the C. Now we'll check whether the current window has every character or not. So we'll see, you can clearly see that A, B and C, all the three characters are present in the current window. So after if we match to this condition, that is every character in the given string T is present in current window, we will check the current window size with minimum window size. This is minimum window size. So we'll check if the minimum window size is greater than this or not. So we'll check, and current window size is 1, 2, 3, 4, 5, 6. So the maximum is greater than 6. So we'll update to 6, and we'll update the start pointer. That is start. These are the index of the given string. So we'll update the answer start to 0, answer end to 5. So this is what I made: 6, 7, 8, 9, 10, 11, and 12. So after finding this, we need to increment the uh, next. I mean, we need to decrease the size of the window, which we will be ignoring the character in the left. So when we ignore the character in the left, initially the count will be 3, because firstly we had 3 characters. So we'll if we remove A, the count of characters present in current window will be reducing. That is, only B and C will be present. So the count will be reduced to 2. So when the count is reduced, we need to extend the window size. So we'll include O. So now to the count is 2. So increment the size of the window to right, and now to we can see only B and C are present in the current window. So we'll increment to E, up to E. So now to the current window, that is starting from 1 to 8, doesn't have every characters of T. Only B and C are present. So increment to B, and now to we can clearly see that there are only 1, 2 characters present in the current substring. So we'll increment the window to index 10. So now we need to check if the current window has every character. So firstly, A is not present, uh, which is included just now. So we'll increment the count to 3. So number of character present is greater than the given, I mean equal to the given string length. So we have every character in our substring, that is B, C and A. So every character present. So we'll check with the minimum window size which we have found. So the current window size is 10 minus 1, which will be 9 plus 1. How will we arrive at the formula? So we can clearly see that we need to count the window size, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we can use the formula like current, that is, let's say we have iterated ith pointer. So ith pointer minus start pointer. This is start pointer plus 1. So it is 10 minus 1 plus 1. So we'll get 10. This is the formula. Wait a second. Formula we'll be using is size window. Let's say WS window size will be current index, let's say I minus start plus 1. This is the formula. So we can see that 10 is greater than 6. So we don't need to update the min value. So we'll start to decrement the size of the window. So we have included from current window is from D to A. So we'll decrement to O, decrement the size by 1. That is, we'll be ignoring the D character. D character is ignored. So O, B, E, C, O, D, E, B, A. So we can say that the count is 3. There are every character present in the current substring, but length is current length is 9, so it is greater than 6. So we'll continue to removing current window size. So we'll be removing O. Now we can see that 1 2 3 all the characters are present, but the current window size is 10 minus 3 n minus start plus 1, so it will be 8, 8, right? So current window size 8, which is greater than the minimum value, so we'll ignore the B. So when we ignore the B, we can see that there are only so sorry, we have still we have three characters which are present in the ABC. So we'll increment decrease the value, so we'll have our current window from 4th index to 10th index. So 10 minus 4 plus 1, which is our current size, is 7. The 7 is lesser than, I mean greater than mean value. So we'll again reduce the window size. So we'll start from E to C to A. So current window size is 10 minus 5 plus 1, which will be 6, which is equal to mean value. So again we'll increment the we'll decrement the window size to by 1. So when we remove the C, we can see that in our current window there are only A, B, that is only two characters present, which are present in the given string T. So we'll decrement the count value to 2, and we need to, we can see that there is one count value is 2, so we need 3 character to match the given T string. So we'll increment the window size by 1. So now too we can see that there are the count is still 2, and of when we include the C, we can see that again there will be increment in count, that is C is added. So current window will be having the current window is from 6th to 12th index. So current window has every character, that is B, A and C. So the count is 3, and we'll check the size. So the size will be n minus start, that is 6 plus 1. The current window size is 7. So 7 is greater than 6. So we'll remove the first character in the window. So the current window is 12 minus 12 minus 7, that is we remove the O. 12 minus 7 plus 1, which will be 6. It is less, it is equal to the minimum value. So we'll again reduce the window size. So the window size will be EBAC. EBAC to the window size is 5, because like uh, 12 minus, let's say E, when we reduce E, 12 minus 9 is 9 plus 1 is 4, which is less than the minimum value. So we'll increment, we'll make the min as 4, and we'll make the answer start to 9 and answer end to 12. So we'll next we'll increment, we'll decrease the value by 1 of window size. So A and C, this window doesn't have any I mean what to say, this window will be having only two count, the count of characters present in current substring. Current window will be 2. Okay, so we need to again increase the value, so there is no more entries left. So we'll exit the loop, and finally we need to return the answer. So the answer will be starting from 9 to 12. So the answer will be B, A and C. So answer is B, A and C. So the main core logic in this question is how we will track this count value. So this count value is used to find the number of characters in our current window, which has the number of characters of T present in the current window. that will be stored in count variable. So how are we going to calculate that count value? We can use a map of character and integer to store the value, I mean the frequencies. So let's create a first frequency map, and we'll be storing every variable, every character's frequency of t to t frequency. And next we'll be having a map of character and integer, that is frequent to store the frequency of each character of the current window size. So let's call it as ws frequencies. So when we'll be increasing the count and when we'll be decreasing the count, this is the core logic of this question. So when we see the current window has, while we iterating uh, the current string yes using ith pointer, I index. So we'll take the character of that index, that is using the formula, using the statement character at I. This is a function which will be returning the character present in the ith index. So we'll check with the frequency of the current character. So if the frequency of current character is less than the frequency of required frequency, which is t frequency, we'll increment the count value. So this will be for including. For excluding, if we are removing the character from the left, we'll check if the current frequency is equal to the frequency of, what to say, frequency of required frequency. If it is equal, we'll reduce the count value. So this is the core logic. So if you are not able to get this solution, you will be very clear if you move on to coding section. So let's dive into the coding section. So firstly we'll create a map. So map of character and integer, it's called as t frequencies, and we'll store every frequency, that is store in is. So for int I equal 0, I less than 3 dot length, sorry is character, let's say 3 dot character at I. So each time we'll put, so before that we need to find the current frequency of the ch character. So let's say a variable freq, and it will be getting the frequency of current data, that is, we can use it to find it as frequency get or default ch 0. So this function get or default function is a function present in map, which we can use to get the frequency of current character, frequency of the key. If the current map has the argument which I have passed, that is ch, it will be returning the value mapped to it, or else 0 will be assigned to the frequency variable. So we'll increment the frequency, that is free plus 1, and we'll store to the map. So after storing the t frequency, we'll have variables like min window size as integer dot max value, and we have ans start -1 and ans end -1, and start as 0 and int I as 0. So firstly we can have a condition like if t dot length is greater than s dot length, will return empty string. So if given t string length is greater than string, so any substring, if we even include every character of s, the window will be less than, window size will be less than the number of characters present in t. So we need to return uh, empty string. That's it. So we'll have ith pointer. So we'll iterate title end of yes. So we need to create another map, that is character and integer, which will be showing window frequencies. Okay, so firstly, we'll get the character. So character is dot character. So after this, we'll see the required frequency. Required frequency is T frequencies get or default CS, 0, and the current frequency, that is the Windows frequency, is window frequencies dot get or default CS, 0. So if required frequency is not equal to 0, we are using this. So we are going to check the condition only if the current required frequency is that is the number of character of present in string t is not equal to 0. So if it is 0, let's say if it is 0, we will increment the I pointer and continue. Else, if first we will have a count variable as count 0. If current frequency is less than required frequency, we need to increment the count variable, and we will put t frequency th and current frequency plus 1. So this is the condition. We are adding the current character to map, and we have incremented the count value. So after this, we check if while count is equal to t dot length, that is the given string 2's length, and I is less than or equal to start. So firstly we'll check get the current window size. Now the window size will be current window size equal to I minus start plus 1. So if current window size is less than minimum window size which I have found, minimum window size will be current window size, and answer start will be start, and answer n will be I. And after this, we need to we have found we have compared with the minimum window, and after this we need to remove the we need to decrease the window size. So what we have done here, we have increased the window size here, and when we decrease the window size, we'll firstly need to check if there is any alteration to count variable. So if so we'll check, we'll get the current frequency of the start. So firstly, in order to decrease the window size, we need to remove the start character, right? So start character need to be removed. So we'll have the start character in ch variable. So s dot character at start. This is the character which we are going to remove from the current window. So we will find the required frequency of that character. So we can find it out by get or default cs, 0, and current frequency of the character can be found out by window current windows frequency dot default cs, 0. So if if required frequency is 0, we can clearly see that the character will have this line and next line. So we can clearly see that we don't need to care about the character which is not present in the T string. So if the condition arises, we'll just increment the start and continue. Else we'll get the current frequency, that is current frequency of character in the window, and if current frequency is equal to required frequency, we'll recommend the count to by 1, and after that we'll change the sequence of current character of current window to by 1. So this comma current frequency minus 1, and finally we'll increment the start variable. So and after that we need to increase the I pointer. So finally we'll have a string answer as if the given minimum is equal to integer dot max value, it's an invalid case. So we'll have so this condition will help us to indicate that no substring is able to be found. So we'll have a empty string, else we'll have a substring as ans start to ans n plus 1. So finally we return ans. So let's check with the line 11. T frequencies getter, sorry, default, and 37th line min window size. So min window size is not cannot find the symbol. So min window size, oh sorry, min window size, oh it's min window size. So what mistake have I done? So increase the window size, decrease the window size. So required frequency, window frequency. So you can use get here. So firstly we'll check the current. Firstly we'll check the logic. So firstly we are storing every data in string to the frequency map, and we are having an integer min value size, min window size. So are we changing the min window size? Yeah, we are changing it, and where we will check whether we are able to do the condition like count is equal to 3 or not. So the count is incremented from 1 to 3. For how is this? So this should not be the case. What mistake have we done? So we'll print the current character. If the required frequency is 0, we'll increment the I and continue. So if current frequency is less than the required frequency, so firstly we'll print the count and index at which the count is received. So when we get to the third index, we are getting fifth index, we are getting the count of 5. 1 2 0 1 2 3 4 5. So it's a valid case. So after the count is 0, we'll get into the while loop. So we'll check the current window size. So after checking current window size, we'll update the minimum window size and also the answer start and end. So after that, we need to decrease the window size. We can decrease it by finding the character start, and required frequency is the frequencies of the present in the string t. So if required frequency is 0, we'll increment the start and continue, or else we need to get the current frequency, and if current frequency is equal to required frequency, we'll decrement the count value and we'll put the current character and current frequency -1. So what are we missing out? So we'll print the count value up. So required frequency is short. So we haven't entered into this condition. So sorry, there's a condition that start is less than equal to I. Okay, so current frequency is get or ch. So required frequency is get or ch and 0. So the current frequency is window size get a default current character get ch. It should work. I don't know why it doesn't work. So let's print and see what mistake I have done. So for character A, so let's check what mistake we have done. Null pointer. Sorry, I'm trying to print this up. So the current character is not present in the window frequency. So sorry, I've done a mistake. So you have to put the current frequency into window frequency. That's working fine. Let's check with other test cases. That's working fine. Let's submit it up. Yeah, accepted. And the time complexity for this approach is order of string length, that is it's given as m. So time complexity for this approach is order of m, and space complexity for this approach is R of m. Why is taking n time? Because we are going to iterate over the complete array, complete characters in this string, maybe it maybe for 2 times. So 2m will be rounded up to m, and the space complexity is actually the space complexity is order of 52, because it is just 52 error, so it will be big of 1. It is a constant space complexity because the map will be containing only up to 52 characters, so as key. So the space complexity constant. The approach for this question is sliding window and hashing. So thanks for watching this video. I think you have learned something out of this video. So have a great time. Happy learning. Thank you.